Is today a work day? A couple of these here. I'm not going to do all of them, but we'll just pick some representative ones and just kind of talk about just a little bit about how we're going to use properties of exponents here. What are we going to do? What do you think? What are some things we got going here? There's a bunch of stuff going on. Sam.
First, you want to flip the fraction to
Good.
get rid of the negative
Perfect.
exponent.
That's a great first step. So yeah, notice we've got this negative exponent. Think what negative exponents do, right? Negative exponents, if you have a negative exponent on the bottom, it becomes positive on the top and vice versa, right? So if you've got a fraction, you can do something very convenient here. You can just take the reciprocal of the fraction and do both things at once and make the exponent positive, right? So the first thing we would do is we would set this equal to the reciprocal of 1 over 9x, which is just 9x, all to the positive 3, and then what do we do? Distribute, sure. Okay. And then that gives us what?
729.
Yeah, 729x cubed, which brings me to my next point. It's really convenient to know your perfect squares and perfect cubes, and so I'm going to make you do that. We're going to do a little quiz here soon. So you got to learn your perfect cubes and perfect squares. So let's make a list. Put this in your notes, and we'll do a quiz. Let's say this Friday over perfect squares. So this is a free. I mean, think about this. This is a pretty good deal for you guys. And then honors algebra 2 class, you get to just do a little memorization quiz. That's. I have not. Haven't even started putting in grades yet. Okay, so let's do perfect squares. So obviously the first ones are, I mean, we'll go all the way up to 15 with them.
One's pretty hard.
Yeah, there's some pretty tough ones here, right? And we could probably even skip everything through 10. We'll do 25 too. That's a good one. Okay, so let's fill in these blanks. I mean, what do we got here?
4,
9,
16, 25, 36,
49,
64, 81, 100.
Okay, then they start to get maybe just a little bit trickier.
121,
Okay, so 11 squared, 121, 12 squared,
44,
13 squared.
196.
Okay, yeah, that's an easy one to remember because when you go to 14, it just flips the digits.
225, 400, 625.
625.
Oh my gosh.
Okay, good. So those are ones, those are, and this is stuff, you know, I mean, just trust me on this one. These are numbers that pop up a lot in math. We're going to be dealing with polynomial functions, and so you're going to be seeing a lot of this kind of thing. A lot of these kinds of numbers squared when we end up doing expansions, binomial expansions and things. So they're just, it's really handy to have those. Okay, let's look at the cubes. Now we won't do such a big list of cubes because they grow pretty quickly. We'll just go up through 10. Two cubed,
8,
3 cubed,
27,
4 cubed,
64,
yep, 5 cubed,
125,
6 cubed, 216, 7 cubed,
343,
8 cubed, 5, 12, good, 9 cubed, yep, 10 cubed. Okay, there you go. I tell you what I'll even do. I'll even put like a resource on Moodle that's got a sheet you can print out if you want. It's got all those on there. How about? Okay. So good to know. Those are good ones to know. Yes.
So is this just like a free pre-assessment grade that we get on the test?
Well, it's not gonna be like a 100-point assessment, but it'll be like a 20 or 25-point assessment.
Okay.
Yeah.
It's gonna be like a 1,000-point assessment.
No, sorry.
Can it literally be worth all of our?
No.
That'd be, this is like the whole entire
Probably
class.
can't do that. Has everybody got this?
Yeah.
I forever love this class. There's so much. That'd be so great.
Oh, yeah, we do. Okay, so let's see here. So moving on, let's take a look at maybe a couple more of these guys. Let's scoot down.
Oh my gosh.
You know, we'll go down
Can we
to
do the one? Yeah, can we do the? What is?
that one.
Yes, please.
Yeah, we can do that one.
What is it?
Okay, so we're supposed to simplify this, and notice the instructions always say write your answer in terms of positive exponents. So what are we probably going to want to do with this?
Flip.
Go ahead. Flip them. Good. We're going to want to flip anything that's got a negative. We want to send it to the other part of the fraction and make it positive, right? So this really is no big deal. We end up with W stays where it is, right? And we want to, when we write these things, we want to write, math is, you know, I'm not an organized person at all. Anybody that knows me well will testify to that.
Yes.
But, true, right?
Yes.
Okay. But when it comes to math, I am very organized. You have to be. In math, you really pay the price if you're not. So you want to do these dumb little things that don't seem like a big deal, like whenever you've got a product of a bunch of exponents, variables, you always want to write those bases in alphabetical order, so you're consistent and it's easy to find your mistakes. It's not going to be, I mean, understand, we're just kind of getting, you know, I'm going to throw some hard stuff at you guys, but really we're just laying the groundwork for doing bigger and better stuff later. I mean, and I don't mean this at all to be scary. I mean, this is actually really cool because you guys are be in the same situation, but you know, when you get to college and you're starting to get into some heavier duty math classes, you're going to be really good at this stuff. I mean, you're going to be to the point where you're going to be able to do problems that just seem inconceivable to you now they'll work. I mean, you will have laid down all the neural pathways to do this stuff. And sometimes the algebra gets pretty big. I mean, it might be just pages and pages and pages of algebra for, you know, to do some big, cool problems. And it doesn't always work, though. That's the thing. I mean, sometimes little mistakes are made, and it's to find those mistakes. And that's something I've got to do a better job of, is maybe, I think sometimes I find your mistakes too much. I think I need to maybe start to make you guys find your own mistakes a little bit more, because that's part of doing math, is being able to troubleshoot and find your own mistakes. But one thing that makes it a ton easier is if you can follow conventions and be very systematic in your algebra. Okay, so we want to put these things in order wherever they show up. So I'm just going to make a fraction, and on the top we'll just kind of put things where they go. The W to the 8th just stays put. Where does the Y end up going? On the bottom. And the Z. And that's my answer. Okay, no big deal. All right, let's maybe move down. Oops. Let's look at some of these. These get a little bit uglier, but that's not horrible, really, is it? What do we do with this guy probably here? Distribute, okay. So we could distribute the 3 to all parts. And so that's going to give us, what's the first base? What exponent will the first base be raised to when I do that? The 3 to the 12, right? Because I'm taking a power to a power, so I multiply exponents, right? So I get 3 to the 12th times x to the negative 18, y to the 9th. Good. And so I can see I'm going to have at least one thing on the bottom, aren't I? Right. So I'll go ahead and set up my fraction bar, and I'll just put the pieces where they go. So 3 to the 12th, yikes, that's going to be a big number, but how could we do that? That's like saying, well, that's just a big number. I don't know, but that's probably a calculator number. What's that give us if we do 3 to the 12? It's gonna be enormous.
I agree.
53141.
Say it again.
53144.
5, 3,
53141.
1, 4, 4, 1, like that. Okay. X goes where? Bottom. Y stays on top. That's our answer. Okay. No biggie. Okay, same kind of thing. Let's maybe just do a, I don't want to spend too much time on these, but there are a few things that it's worth talking about. Any suggestions on this one? And let's really, there's a bunch of different ways we can do this, but much of what we do is not just about doing the problem, but about doing it the most efficient way we can. Sam, you got a suggestion?
Can you reduce the flow right off the bat?
Yes, and in fact, that's a great idea. We should start off by working inside the quantity, right? And do as much work in there as we can so we can get the numbers smaller and make things simpler, right? For example, let's look at the numbers. I mean, these aren't horrible numbers, but if I were just to distribute the power directly, I'm gonna get 64 over 16, and you gotta think a little bit about that, but 8 over 4 is pretty simple. What's 8 over 4? 2, right? So inside the parentheses, then, we're going to get a 2 on the top. That's going to take care of those guys, right? What about the V's?
1 over 3.
Where are the V's going to end up?
These
On
are
the
the
bottom.
bottom.
They're going to go to the bottom, aren't they? Because remember our rule. We said when we divide like bases, if we're trying to write in terms of positive exponents, remember that trick I showed you? What we can always do is we can ask ourselves initially, okay, where does the base have the biggest exponent or the most power? And that's where it stays, right? So in this case, it's on the bottom. So we'll keep the V on the bottom, and then we'll subtract the 3 from the 9, right? So we get V to the 6th. How about the X's? Well, X's stay on the bottom, and the Y's stay on the top. And so finally now we can just distribute that exponent to all the factors, right? And what's that going to give us? So it's going to give us a 4 y to the 10th, v to the 12th, and x to the 16th. Yeah. Okay? Questions? All right. Oh, man. Okay, looks pretty ugly. We don't have to even maybe do the whole thing, but how are we going to simplify this? We'll do it real quick. So there's really nothing we can do to the first factor. What about the second one? Distribute the exponent. Good. So we're going to end up, first factor is going to stay the same. What about the second one when we distribute that exponent? Negative 5 cubed is what? 125. And then y to the 9th, z. Okay. How about this guy over here? Last one. Okay, yeah, so the question is, so is it negative 16? It's not, because here's the thing I want to get at this time. When we distribute that 2, we're distributing it to the quantity negative 4. There's always a really simple rule you can remember when it comes to the signs of power functions, right? If you take a negative exponent to a negative number to an even exponent, the outcome will always be positive. A negative number to an odd power will always be negative. Good. Okay, so then this one we can see we're going to get positive 16, and then what? Y to the 4th. So now all we've got to do is just multiply through, right? And the way I like to divide this up, I like to think about it in terms of the numbers or the coefficients. Let's take care of that one first. That'll always be the hardest part. The variables are going to be really simple comparatively. But the numbers, they get big. So our final answer, 6 times negative 125 is going to be what? 850? No, 750 times 16. So that's 7,500 plus 900. What? Is that 8,400? Is that right? Somebody check me on that. Use your calculator. I think that's right, but I might have messed that up. Is that right? What'd you get? Oh, I was way off. Is that right? 750 times. Are you sure? 6 times 125 times. What is it? 12,000. Okay. Oh, I was way off. That's embarrassing. And it's going to be negative, isn't it? Negative 12,000, and then let's see, do we have any x's? No. What's the first variable we run into alphabetically? Y, I guess? So what's y going to be to? 13, good, because when you multiply like bases, you add exponents. Good, so y to the 13, and then z to the what? 8th. Okay? Make sense? We good? Okay, same kind of stuff. I'm not going to worry about that one. Okay, if we look at the last assignment, there's a couple on here I just want to quickly touch on. Okay, so what's the first thing we're going to do with this one? I'd say no. Get everything onto the right side. Okay. Yeah, let's go ahead and just flip the fraction and get rid of that outside one, right? Although I guess what maybe you guys were seeing was these were all negative, and so distributing makes them positive. Were you thinking that?
So you just get the extra order.
Okay, I guess I could see that. Okay. Okay, I'm buying it. So I guess I don't need the parentheses anymore then if I distribute. So if I distribute the negative 2 power, what's that going to do? See if we can do this in one step. What's that going to do to the 6? Okay, it's going to give you 6 to the negative 2, which is going to be 1 over 6 to the positive 2, right? Everybody agree? So what is that then? Where's the number end up? And it's going to be a 36. Okay, what's next in order? Looks like V's. So we're going to get V to the, when I distribute the negative 2, we get V to the positive 6. So that stays on top. What about the Y's? What happens here with the Y's?
Y1 is y to the 0 is reduced to 1.
Okay, so that's reduced to 1. Good. And we could even think about those y's as being combined, right? So where do those y's have the most power, 0 or negative 7? Well, actually, 0 is bigger than negative 7. I mean, I know, but you could. A couple of ways to think about this. One way to think about it would be to say, okay, 0 is bigger than negative 7, so let's keep the y on the bottom, and well, actually we haven't distributed yet, right? Before we distribute, on the bottom we're going to get a y to the 7, right? So the intermediate step is going to be we get a y to the 7th on the bottom, but then we're going to distribute that negative 2, which does what? Good, which makes it negative, so it sends it back to the top. I'm not pretending that's the only way to do it. You could have distributed first and then flipped them all. So personally, I would have, the way I always do these is I always flip the fraction and make that exponent positive. To me, I think my own personal bias, I think you're more likely to make a mistake distributing negative exponents than distributing positive exponents. Yes?
Couldn't you have also just made y to the 0 equal 1 and therefore it just cancels out?
Yep,
Flip the y
you
to the
could.
bottom?
You could, right. You could just cancel it. So on the top, we get y to the 14th. Now, what about the z's? On the bottom, I'm going to get a positive 4. Good. Okay, so that's our answer. So this isn't a big deal, really, right? These kinds of questions come up a lot though, on tests, standardized tests. Okay. Okay, no biggie. I'm skipping that. Okay, on this one, what do we probably want to do before we do anything else with this one, before we distribute the exponent? What do we want to do? Simplify, right? We want to build one coefficient or at least reduce the fraction, and we'd like to combine variables inside the quantity first, right? And then we'll distribute, okay? And then finally, we got some properties of exponents with geometry. Well, if we're trying to find a volume here, what do we do to find a volume if we go back to geometry? What do we do? Somebody raise your hand. A right rectangular prism. Yes, sir. Duncan. Hey, listen, we got way too much talking. Please don't talk. Yes. Multiply, right? We just multiply all the dimensions together. So this is and it's just going to be the product of those measurements, right? No big deal. You guys can do that. There's one on here, if I remember right, that's a little trickier. So that's no big deal.
It's one of the last.
Yeah, I think. Okay, so that one I think is a little bit trickier. How are you going to think about this one? Now look what they're giving you. Yeah, I'd strongly recommend everybody really be watching this because you're going to have to do this assignment. I mean, we're like right away. So they're telling us the volume of the cube, right? This is just it's a cube. So the cube, it's just going to be the product of the 3 dimensions, right? They want us to find the missing dimension, right? So how could we set up an equation then to solve for that missing dimension? What do you think? Somebody who hasn't, yeah, Chris, what do you think?
The volume equals 2 cubic sides and then x.
Ah, okay. So the volume is going to equal the product of those 2 things and something else. Call it capital X, right? And then capital X is going to be maybe the missing dimension, right? And that's going to be equal to that, right? And then we just have to isolate what we call capital X, right? The missing dimension, and algebraically, and then once we do that, that's the missing dimension. Okay? Make sense?
Yeah.
Okay? No biggie. All right. So that's that. All right. What I want to do, how much time we got?
6 minutes.
6 minutes. Okay. We don't have a ton of time, but I want to maybe show you one cool thing for today, and then tomorrow we'll pick up with this new stuff. Let's look at. I want to show you something that I show my calculus classes all the time. Okay, let's look at a function here in Desmos, and here's my function. My function is right there. Everybody see that? So write that down in your notebooks, because we're going to explore this function a little bit. I want you to see something really important about this. Well, we're going to talk about.
How many zeros?
It's point 1, 2, 3, 4, 5, and then a 1. X to the 4th. Okay. And maybe before we do this, even, I think before we even do this, I want to do one quick refresher on something. So.
Whose birthday?
can still, yeah, good. I can still keep that one. Let's look at, I want to just look at a couple quick functions. We just want to remind ourselves what functions look like. So let's look at the power function x squared. It's a parabola, right? No big deal, okay? Let's compare that to x cubed, okay? It looks different, right? Let's kind of remind ourselves, it's been a while since we talked about this, but let's talk about the symmetry. Does the red parabola have even or odd symmetry? Has even symmetry, and I'm not going to remind you about the algebraic test or the functional test for symmetry. Let's just think about the graphical test for even symmetry. What kind of graphical symmetry does even symmetry represent? Reflection about the y-axis. Good. Okay, so we can fold the red function onto itself over the y-axis. The blue function, the cubic function, is even or odd? Odd. Okay, this is the one that's a little bit weirder that we haven't dealt with as much maybe up to this point in your math careers. What's the graphical meaning of odd symmetry? That's the weird one for now. It'll seem pretty normal soon. But remember what you do to get, how does the red one folds on itself? Okay, over the y equals x. Now that's the symmetry that inverse relations have.
Y equals something else.
No, it looks like it could be, but what I'll tell you is it's not folding symmetry or reflective symmetry. It's something different. It's not. It's not mirror symmetry. It's rotational symmetry. About what point? The origin. Yeah. So here's what you do. Imagine that you put a tack at the origin and you're going to spin the function 180 degrees. Right? That's what rotational symmetry is. So we spin it 180 degrees about that tack and then it lines up with itself, right? Well, notice what happens if we just keep this process going. What do you think x to the fourth is going to look like? It looks an awful lot like the parabola. It's just been changed very slightly, right? What about x to the fifth? See what I'm saying?
Did you hand yours in? Did you?
Yeah, I did. I did. Yeah, thanks. Yeah.
Like Eric, I gotta take care of you.
Yeah.
We all need those moments.
Yeah, we do. We do. Thanks. Okay, so I know you guys got to go, but you see what happens here? One last thing. Look real quick. Now, then you got to go. Notice that as the functions get more powerful, look what happens graphically. They just get more squared off, right? So instead of looking like a nice smooth parabola, the green one starts to look a little boxier on the bottom. Instead of looking like that nice smooth cubic, the orange one kind of gets more squared off. And we'll talk about why that is maybe, tomorrow. But there's
Does it become a cube if you keep putting the things on it?
what's that?
It's like x to the 10th.
Yeah, so let's try one. See, what do you think if I take like x to the 100th?
X to 100. Oh, shoot!
Look at that.
It's crazy.
Yeah. Yeah.
If you did the little circle formula and you put like x to the 100th and y to the 100th, does it become a cube?
No. No, it doesn't. That's a good question, though. We'll try it tomorrow. We'll take a look and see what happens with those. Yeah.